Hello students, welcome to Grade 10 Science Lesson. And I'm your teacher, Ma'am Marianne. You have learned from our previous lesson the great contributions of these famous scientists on understanding electromagnetic waves. Their scientific contributions help us understand the different characteristics and uses of EM waves in our lives. There are 7 known EM waves. These are radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. These EM waves are arranged in the electromagnetic spectrum based on their wavelength, frequency, and energy. Notice that as you move from left to right of the electromagnetic spectrum, the wavelength becomes shorter while frequency and energy increases. That's why EM waves with more energy can be classified as ionizing radiation. Examples of these are X-rays and gamma rays. While EM waves with less energy are called non-ionizing radiation, just like radio waves, microwaves, infrared, visible light, and ultraviolet rays. Let's learn more of the uses and effects of these EM waves in our lives. Lesson 3. Uses and effects of electromagnetic waves. Let's start first with the lowest frequency but has the longest wavelength, radio waves. Radio waves have the longest wavelength in the EM spectrum, ranging from about 0.04 inches or 1 millimeter to more than 62 miles or 100 kilometers. Radio waves also have the lowest frequencies from about 3,000 cycles per second or 3 kilohertz up to about 300 billion hertz or 300 gigahertz. In 1886, Henry Hertz, a German physicist, applied Maxwell's theories on an experiment and became the first person to transmit and receive controlled radio waves. That's why the unit of frequency of an EM wave, 1 cycle per second, is called a hertz, in his honor. Radio waves are a type of electromagnetic radiation best known for their use in communication technologies, such as radios, televisions, and mobile phones. Here is an example on how radio waves works in radio communication. First, sound waves enter the microphone and are converted into electrical impulses. Next, the electrical impulses are converted into radio waves and broadcast by the transmitter. And lastly, the radio waves reach a radio receiver and are converted back into sound. Radio wave spectrum can be arranged into 9 bands. We have extremely low frequency, followed by very low frequency. Next, we have low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and lastly, extremely high frequency. Let's take a look closer on the different uses of these 9 bands of radio waves. Uses of radio waves with low to medium frequencies. The ELF radio waves, the lowest of all radio frequencies, have a long range and are useful in penetrating water and rock for communication with submarines and inside mines and caves. Did you know? The most powerful natural source of ELF or VLF waves is lightning. The waves produced by lightning can bounce back and forth between Earth and the ionosphere. These lightning disturbances can distort important radio signals traveling to satellites. The low-frequency and medium-frequency radio bands include marine and aviation radio, as well as commercial AM or amplitude modulation radio. AM radio has a long range, particularly at night when the ionosphere is better at refracting the waves back to Earth, but still it is subject to interference that affects the sound quality. Next are the uses of radio waves with higher frequencies. High frequency, very high frequency, and ultra high frequency bands includes FM radio, broadcast television sound, public service radio, cell phones, and GPS or global positioning system. These bands typically use frequency modulation or FM to encode an audio or data signal onto the carrier wave. In frequency modulation, the amplitude of the signal remains constant while the frequency is varied higher or lower at a rate and magnitude corresponding to the audio or data signal. That's why FM results in better signal quality than AM because environmental factors do not affect the frequency the way they affect amplitude, and the receiver ignores variation in amplitude as long as the signal remains above a minimum threshold. The shortwave radio uses frequency in the HF band from about 1.7 MHz to 30 MHz, which is used for broadcasting. Shortwave stations can be heard from thousands of miles because the signal bounce off the ionosphere and rebound back hundreds or thousands of miles from their point of origin. And lastly, the uses of super high frequency and extremely high frequency represent the highest frequencies in the radio wave band and are sometimes considered to be part of the microwave band. These radio wave bands are less affected, that is why used for short-range applications such as Wi-Fi, Bluetooth, and wireless USB. Since wave bounce off objects, these radio wave bands can also be used for radar. Since you now know the different uses of radio waves, the next type of EM wave is known as microwaves. Microwaves cause water and fat molecules to vibrate, which makes the substances hot. So we can use microwaves to cook many types of food. Mobile phones use microwaves as they can be generated by small antenna, which means that the phone doesn't need to be very big. Wi-Fi also uses microwaves. Microwaves are also used by fixed traffic speed cameras and for radar, which is used by aircraft, ships, and weather forecasters. The danger side of prolonged exposure to significant levels of microwave is known to cause cataracts in your eyes, which is a clouding of the lens preventing you from seeing clearly. So, don't make a habit of pressing your face against the microwave oven door to see if your food is ready. Also, people who work on aircraft carrier decks wear special suits which reflect microwaves to avoid being cooked by the powerful radar units in modern military planes. Next type of EM wave, the uses of infrared. Infrared waves are just below visible red light in the electromagnetic spectrum. Infra means below. You probably think of infrared waves as heat because they are given off by hot objects and you can feel them as warmth on your skin. Infrared waves are also given off by stars, lamps, flames, and anything else that's warm, including you. Infrared or IR are also used for many tasks such as remote controls for TVs and video recorders. Psychotherapies use heat lamps to help heal sports injuries. IR is also used for short-range communications, for example between mobile phones or for the Dolby Screen Talk headset system used in some cinemas. Because every object gives off IR waves, we can use them to see in the dark. Night sights for weapons sometimes use a sensitive IR detector. One of the most common modern use for IR is in the field of security. Passive infrared or PIR detectors are used in burglar alarm systems and to control the security lighting that many people have fitted outside their houses. These detect the infrared emitted by people and animals. You've probably seen TV programs in which police helicopters track criminals at night using thermal imaging cameras which can see in the dark. Weather forecasters use satellite pictures to see what's heading our way. Some of the images they use are taken using IR cameras because they show cloud and rain patterns more clearly. Next is the only type of EM wave that can be seen by human eyes: visible light or white light. Our eyes can detect only a tiny part of the electromagnetic spectrum called visible light. White light is actually made up of a whole range of colors mixed together. Light waves can also be made using a laser. Lasers are used in compact disc and DVD players, where the light is reflected from the tiny pits in the disc and the pattern is detected and translated into sound or data. Lasers are also used in laser printers and aircraft weapon aiming systems. Remember, too much light can damage the retina in your eye. This can happen when you look at something very bright. So avoid looking at something very bright, such as the sun. Although the damage can heal, if it's too bad, it will be permanent. You might know this type of EM wave as UVA, UVB, or UVC. This is ultraviolet ray. Uses of UV light include getting a suntan, detecting forged banknotes in shops, and hardening some types of dental filing. You also see UV lamps in clubs where they make your clothes glow. This happens because substances in washing powder fluoresce when UV light strikes them. They absorb the UV and then re-radiate the energy at a longer wavelength. Ultraviolet rays can be used to kill microbes. Hospitals use UV lamps to sterilize surgical equipment and the air in operating theaters. Food and drug companies also use UV lamps to sterilize their products. Suitable doses of ultraviolet rays cause the body to produce vitamin D, and this is used by doctors to treat vitamin D deficiency and some skin disorders. Large doses of UV can damage the retina in your eyes, so it's important to check that your sunglasses will block UV light. Large doses of UV cause sunburn and even skin cancer. Fortunately, the ozone layer in the Earth's atmosphere screens us from most of the UV given off by the sun. Classified as part of ionizing radiation, this type of EM wave is known as X-rays. X-rays are very high-frequency waves and carry a lot of energy. They will pass through most substances, and this makes them useful in medicine and industry to see inside things. X-rays are used by doctors to see what's inside people. X-rays are also used in airport security checks to see inside your luggage. They are also used by astronomers. Many objects in the universe emit X-rays, which we can detect using suitable radio telescopes. Lower energy X-rays don't pass through tissues as easily and can be used to scan soft areas such as the brain. Too much X-rays can cause cell damage and cancers. This is why radiographers in hospitals stand behind a shield when they X-ray their patients. Although the dose is not enough to put the patient at risk, they take many images each day and could quickly build up a dangerous dose themselves. The EM wave that has the highest frequency but shortest wavelength, gamma rays. Gamma rays are given off by stars and by some radioactive substances. They are extremely high-frequency waves and carry a large amount of energy. They pass through most materials and are quite difficult to stop. You need a lead or concrete in order to block them out. Because gamma rays can kill living cells, they are used to kill cancer cells without having to resort to difficult surgery. This is called radiotherapy and works because healthy cells can repair themselves fairly well when damaged by gamma rays, but cancer cells can't. Gamma rays kill microbes and are used to sterilize food so that it will keep fresh for longer. This is known as irradiated food. Gamma rays are also used to sterilize medical equipment. Gamma rays are dangerous in a way that gamma rays cause cell damage and can cause a variety of cancers. They cause mutations in growing tissues, so unborn babies are especially vulnerable. To summarize what you have learned, According to electromagnetic waves' frequency and energy, they can be classified as either ionizing or non-ionizing radiations. The entire electromagnetic spectrum, from the lowest to the highest frequency or longest to shortest wavelength, includes all radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Nearly all frequencies and wavelengths of electromagnetic radiation can be used for spectroscopy. Spectroscopy is the study of the interaction between matter and electromagnetic radiation as a function of the wavelength or frequency of the radiation. I hope you learned and enjoyed our lesson. This is Ma'am Marianne Soriano. See you in the next lesson.